Hello, it's a pleasure to meet you all again in my mathematics class. Today, let me explain how to solve a traveling salesman problem. What is traveling salesman problem and what is the importance of this traveling salesman problem? It was well explained in my last class. And you see that every company is very conscious of its expenditure on conveyance, or rather on traveling allowance, dime allowance like that, which they pay to their representatives or their people who go for canvassing their products. For such people who go on, go to cities or go to places, go to cities or the places where the company is doing business to canvass for their products. The company has to bear the expenses of their representatives, but the company will always keep in its mind that the expenditure on the representatives must be minimum as possible. And since I talk about the minimum, naturally you see that our optimization techniques come. And here is this problem where I am going to apply the optimization technique. You see that here, I will explain this. There is a salesman who has to visit the cities A, B, C, D and E. And that the distance from A to other cities B, C, D, E, and from one city to other cities, the distance in kilometers are given here. For example, you see that B to D is 3 kilometers, B to E is 4 kilometers, and C to D is 7 kilometers. Like that, you find that the elements in this matrix refer to the distance in kilometers. Now, the aim of this problem is to find the shortest distance between the cities so that the overall distance covered by the salesman is minimum, and naturally the expenditure, the conveyance expenditure has to come down, has to be minimum. So this is the aim of this particular problem. And so you see here, you can find this dash coming in this principal diagonal elements. The principal diagonal elements are left vacant, in the sense there is a dash, for which it means that there is no distance between A and E. If you go from A to A city, if you are going to do a business in the same city, the distance that you travel is not taken into account. That is, you have to go, stay there and do the business, and how much ever kilometer walk, it is not going to matter at all. So A to A, there is no distance. And B to B, there is no distance. C to C, there is no distance. That means we take, so in order to not to commit mistakes, I will explain these things while I am working out the problem. You see that I will simply mark these places as infinity. I will mark this as infinity. The reason is that infinity is the maximum, it is the ultimate number. If you add anything with that, it is going to be infinity. And if you subtract also any amount, whatever be the amount that you are going to subtract, it is going to remain infinity. Infinity is infinity. It is not going to be altered for any reasons like addition or subtraction. So you see that this remains unchanged throughout. Okay, now, so you see that with this small idea and about the aim of the problem, let us start doing this. And this problem, doing this, it is also an assignment problem only. Assignment problem, as I told you, that you are going to assign the jobs to missionaries or jobs to persons in such a way that the overall cost. The objective function may be cost, objective function may be time, objective function may be some expenditure. So this, and sometimes if these or that, it is going to be minimization, and there can also be maximization. A problem has been done on that. So a maximization can also be there if the objective happens to be the problem of maximizing profit or maximizing the income. Can you understand? So you see that with this is what is required of a student to know. Okay, now so we have got this matrix, and this matrix A, B, C, D are the cities. Now the traveling salesman is going to travel from city to city to do the business, so that and say that he does not, that is, he is taking the shortest route possible. Okay, we have got what is called a route condition. Here the only thing is, the only thing that traveling salesman has to bear in mind is the condition of route, that is the condition, he is route condition. What is the meaning of route condition? A traveling salesman starts from a headquarters. For example, he starts from Chennai. He is supposed to visit 5 cities or 5 places, you can say anything. 5 cities, 5, let us take it to be 5 cities. He has to visit 5 cities for canvassing for his product. So he has to go from city to city. Now what is expected of him is that he has to necessarily visit all the cities. Okay, number 1. Number 2 is that he has to take the shortest route, and he is not supposed to come back to a place again for doing the business. That means he has to visit every place not more than once. So not more than once, and that the shortest route. Not more than we will that sort of a problem we will come across only at the end of the solution. At the end of the solution. But the shortest route is nothing but an assignment problem. What does it mean? Here we have to use the method, assignment method, that is solving an assignment problem. Namely, I have taught you Hungarian method to find out the shortest distance between places. Can you understand? From city to city, so that the overall distance is shortened, and that after finding how he is going to take a itinerary means what? A to B, A to C, A to something like that. But he has to visit every place once, and completing that he can come back to his headquarters. Visiting the headquarters second time is allowed, but not other places. So he has to come back. Now while he comes back, he must see that the route conditions are satisfied. That is, he does not visit any place twice, and that he visits all the places and comes back successfully to his headquarters city. Can you understand? So this is, so assignment problem is a minimization problem. So here we are going to find the minimum distance the traveling salesman has to travel. So this is nothing but a minimization problem. So they may ask you in your examination, why traveling salesman problem is a minimization problem? It is a minimization problem because the traveling salesman has to take the shortest distance between cities to cities. So that, what does it mean? It is nothing but a minimization of distance. Hence, the objective is minimize the distance. So objective function is your function which is the distance. So that distance has to minimize. Therefore, this is a minimization problem. Now, let us start doing the problem. I have taught you the Hungarian method. So this is the route condition. I told you what is the route condition. They will ask you in your university examination what is the meaning of a route, what is the meaning of route condition, and that we will use Hungarian method. Hungarian. What is the meaning of Hungarian method? So understand that these infinities are put just to safeguard ourselves, so that we will not assign this. We cannot assign that. Take it from me. Okay. Now you take this. Now what is the first? Say, I'll repeat again and again, so the students who are watching or for the first time, they will also learn by just watching this video, and it may not be necessary for you to go to the other videos, the other classes that I have handled. Okay, now you see that what is the minimum here? Here the minimum, row minimum is 3. Now you see that subtract this 3 from every element. So infinity minus 3 is infinity only. I told you infinity minus anything is infinity, infinity plus anything is infinity. So you see that 4 minus 3 is 1, 7 minus 3 is 4, 3 minus 3 is 0, 4 minus 3 is 1. And here likewise, what is the minimum here? Again 3. So 4 minus 3 is 1, this is infinity, this is 3, this is 0, this is 1. And coming here, which is the minimum here? 5 is the minimum. So it is 2, it is 1, and it is infinity, it is 2, and sorry, this is 2, and the next is 0. And coming to this, what is the minimum? Minimum is 3. So 0, 0, and it is 4, and it is 0, and it is 4. And last one is, which is the minimum here? 4 is the minimum. So it is 0, it is 0, it is 1, it is 3, it is infinity. So you see that infinity addition with any infinity is 0. Subtraction with infinity is also infinity. So you see that another thing that I want to tell you is that if you adding a constant or subtracting constants from rows and columns will not change the optimality of the assignment problem. This is also very, very important. I have explained enough in my last class. Okay, now so you see that this one, now you just see whether every row will have a 0, but you just check whether every column has a 0. If not, choose the minimum of the column subtracted from every element in that column. Now you see that this one, it is infinity, 1, 2, 0, 0, and next one is 1, infinity, 1, 0, 0. And here you see that there is no zeros. 1 is the minimum element, so 3, it is 2, it is infinity, it is 3, it is 0. Next is 0, 0, 2, infinity, 3. Next is 1, 1, 0, 4, and infinity. So this is what I have. Now you see that I am able to bring 1 0 in every column and every row. After achieving that, start the assignment. What is the meaning of assignment? Go to see, understand that here A, B, C, D are here. A, B, C, D, everywhere there, that one. City, places. Now, if there be 1 0 in a row, assign it. If there be more than 1, just leave it. Okay? Defer it. Defer means don't postpone it. Then go to the next row. Go by row wise, then column wise, row wise, column wise, unless and until all these zeros are either assigned or marked. I have taught enough on what is the meaning of this assignment and marking. So go through that, my previous class, you will understand better. So you see that, but yet still I explain things again and again so that you people will understand. So you see that here, if there be 1 0, assign it, and if there be more than 1 0, defer it. In the sense, just postpone it. When you go for row wise assignment, column wise assignment, again repeat that again and again so that all zeros are either assigned or marked. Okay, now you see that here this 1 0. Now go to this first row. You see that there is only 1 0. What does it mean? You assign it. No other go, you have to assign it. What is the meaning of this? The city A, the traveling salesman starts from A and he goes to D now. So what does it mean? He goes to D. That is the meaning of that. Later on explain more on that. But understand what is the meaning of assignment. The traveling salesman starts from A, city A, and he goes to city D. That is the meaning of that. While you do that, you see that the traveling salesman at the same time cannot go to 2 different places. That is not possible at all. So you see that here are 2 here B, that is this 0 has to be marked. That is the method of doing it is, when you assign a 0, you mark the zeros which are above and below, and also sidewise, So you see that here there is 1 0, it is here, just mark it. So in the sense that here it has got a meaning that D he will not, that is he will go to only D. In this particular case, A will go to D, A will go to city D. Okay, now so mark it like this. Then come to the second row, there is no 0, but there was 1 0 which has been marked, so don't worry about this. Come to the third row, see there is 1 0, so assign it, and then go no zeros up above, so you see that, so you can just leave it. Then come to the fourth row, see there are 2 zeros, so don't do anything. Come to the fifth row, you have got 3 zeros, so don't assign, we will automatically we will do it, don't worry about that. Then after exhausting row wise, then go column wise. Go to the first column, there are 2 zeros, don't assign. Come to the second column, 2 zeros, don't assign. Come to the third one, so there is only 1. So you see that assign this simultaneously, all this must be cut. If you have any zeros, cut them also. Then come to the fourth column, no zeros, so you see that no zeros available, open zeros I mean, and fifth column no, so column wise exhausted. Again go row wise, unless and until all the zeros are assigned or marked. Come to the first row, you cannot do. Second row, nothing can be done. Third row, nothing can be done. Fourth row, you see that there are 2 zeros, so don't do anything, we cannot do anything. Then fifth row already has been done. Then go for column wise. If you go column wise, first column there is only 1, so you just go for this, mark this, that's all. Now you just see, go row wise, you find that all the zeros are either marked or assigned. Second row, again it is marked or assigned. Third row, yes. Now you find that here there is one assignment, there is no assignment in the second row, there is assignment in the third row, there is assignment in the fourth row, there is assignment in the fifth row. That means you have assigned the cities, but here you see that B city, from B city where is he going, no one knows. Where is he going? The traveling man, salesman, where does he, is he coming to B? From B, where is he going to go? Nothing is known. So you see that the solution is not optimal. Can you understand? The solution is not optimal as long as the assignments are not complete. See, as I told you in my previous classes, that if there are 5 machines, then there must be 5 jobs, and every machine has to be given a job, and every job has to be given a machinery. Can you understand? It's 1 to 1. So here you see that it is not assigned, so it means that the solution is not optimal. Now what is that you have to do? When it is not optimal, you have to tick that row, or rows, maybe rows also, that row which does not have an assignment. So this row is not having an assignment. This is the only row not having an assignment. If there be any other row having no assignments, that has also to be marked. So here in our particular case, we are lucky that there is second row is the only one which is not having an assignment. Then move along that row and tick that column which has got a marked 0. This is a marked 0, tick that. Here again you must know that if there be any here marked 0, this column has to be marked. Can you understand? You have to mark all the tick all the columns which has marked zeros. That you must remember. Then after then move along this ticked column and tick that row which has an assignment. So you see that, go over this and tick. Likewise, if you have any, here also if you have a marked 0, you will tick this column, move along this and tick that row which has an assignment. This has to be repeated. You have to repeat this process, ticking the row, column, row, everything, unless and until it stops at one stage. Can you understand? Further cannot be extended. Till then you have to do this. Now, so this is what I have done here. Now, after then, draw thin lines on the unticked rows unticked columns. So what does it mean? This is 1, this one, unticked column. Okay. Now then choose the minimum of the open numbers. What is the open number here? Your open number is 1. It is the minimum. So choose that minimum and subtract from every other open number and add with the numbers at the intersection of the horizontal and vertical lines. Now take this one. Infinity minus 1 is 1. 1 minus 1 is 0. 3 minus 1 is 2. Then 0. Then take the next one. It is 0. It is infinity. 2 minus 1 is 1. 0. It is not at the intersection. It is just it is like that. So it is 0. Then it is 0. Then come to the next one. See, you have to do subtract from open numbers and add with the number at the intersection of the lines. No other numbers should be left undisturbed. Okay. So this is 2 and this is 1. This is infinity. 2 plus 1 is 3 because at the intersection. Then it is 0. Then it is 0. Then 3. Then infinity. Infinity plus 1 is infinity only. And next is 4. And come to this. It is 0. It is 0. It is 0. It is 3 plus 1 is 4. And it is infinity. So we have got a new matrix like this. Now after doing this, you start assignment. What is that? You will go for assignments again. Now go for the assignments now. What is assignment? Here there are 3 zeros. Don't do anything. Come to this. There are 3 zeros. Here there is only 1 0. Okay. Mark this. Simultaneously cut this. Then come to the next one. 2 zeros. Come to the next 3 zeros. You cannot do anything. Come to this. 3 zeros. Come to this. 3 zeros. Come to this. You have got 1 0 here. Do this. Mark all this. Come to this. There are 2 zeros. Here zeros are marked or zeros are assigned. So leave it. Then row wise again. There are 2 zeros. There are 2 zeros. Here there are 2 zeros. You cannot do. Come to this column. 2 zeros. 2 zeros. Here 2 zeros. Now you see that here we get into some problems here. Now when you do this, let me take the first row here. 2 zeros. See, go to the problem and see whether, see, this one you can compare. This is 4 and this is 3. This is 4 and 3. So the minimum distance you are going for minimization. So this is 4 and 3. So since this happens to be your minimum, you can mark it. When you mark this, mark this thing. When you assign this, you have to mark. When you assign this, can you understand how I have done this? Because I am not able to, there are 2 zeros in a row and 2 zeros in a column. I am not able to I am not able to be sure which one to be marked, which one to be assigned, which one has to be assigned. So I am in a confusion. So what I do is I go to the original matrix and find out which is the short. See, there is 1 0 here, another 0 here. Between these zeros, where the minimum distance is what? 3. So I go for marking that 3. Can you understand? You can take anything and do. Even you can take anything and do. But I go by this. I take this and take 0. And therefore, when you mark this, you have to, when you assign this, mark this and mark this also. Now, come to the second row. You see that in the second row, this is marked. So simultaneously cut this. Come to the third one, marked. Come to the fourth one, you just see that this is marked and it is submitted. Now you see that this problem is, now there is 1 0, assignment, 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 assignment and assignment. Now what is that you are having now? So it is, so he is A, B, C, D, E. A, B, C, D, E. Now root. What is the root? A he goes from A to D. and he from goes to D to B, and B to A, see, and he goes from C to E and comes back to C. So you see that we have found the minimum distance, we have used the assignment problem, and we are able to get the minimum distance. The assignment as minimum distance, that is the shortest distance we are able to find between cities. But you see that we have the root condition is violated here. Our root condition is not satisfied. He goes from A to D and D to B and B to A. He comes back to B A again. That is not allowed. And he is from C to E goes, and from E to C he comes. See what? It is not satisfying the root condition. Now you must see that the root condition is not satisfied. That means what? You have to take, let us think of, see, when you come across a situation where the root condition is not satisfied, you can go for assignment with respect to the next least element. Here you see that the assignment is done with respect to zeros. 0 happens to be the least number, positive number here, and least number, it is 0. It is not about, it is a least number. And when you come across situations of this type where the assignment is not, that is the root condition is not satisfied in traveling salesman problem, just go for the next least number assignment. You go for assignment with respect to that, and change the assignments so that you will get it all right. In the sense, here you see that next to 0, this 1 happens to be your next list. So instead of assigning this 0, you try to go for this, try to go for assigning this, and accordingly you change the roots. Can you understand? So you see that what I will do here is, instead of this, I will write here, instead of this, let me choose this. That is, I will assign this. If I assign this, this will be cut off. This will be cut off, and you see that this will also be cut off, because you have to, when it is assigned here, whether it is 0 or 1 has to be marked. Can you understand? Here this has to be marked because you are assigning here. Then when this is done, you see that this 1, see, this is over, and here when this is done, when you assign, when this becomes this one, these two will be your open zeros. Here these two will be your open zeros, and this is assigned, this is assigned. When this is not assigned, this is open, this is open, and this is open. Here there is an assignment, here there is an assignment, here there is an assignment, here there is an assignment. So you see that there is no assignment here. So you see that when you mark this, you see that these two zeros are open. That means what? This is cut. These three are, this is assigned means this is marked. This is assigned means this is marked. And here you see that I go for a slight change of this. So here I want to see that A to D, then D to B, and B to C, C to E, and E. So you see that here this is marked. This is, so you see that here I will write here. So this is marked because this is assigned, this is marked. And here you see that this is assigned, therefore these two are marked. This is not marked. Okay, now this is assigned, therefore this is marked. This is correct. This is correct. Oh. So you see that this is assigned, therefore this is marked, and this is also marked. Now the open only is this one. So you see that this you can just mark it. So you see that what happens here is that I will go for a change. See, instead of 0, I assign this. When I assign this, this has to be marked. And here you see that since this is assigned, this has to be marked. And when this is assigned, this is marked. So this is marked, this becomes a assigned one. So you see that this becomes an assigned one. So what is that I have done here? Here it comes just by inspection and also going through analytic, that is, use your reasoning, you will get. So you see that this is assigned, and since 0 is not giving the proper assignment, what I do is, instead of this 0, I take this 1 here. So when I mark this 1 as assignment, naturally this becomes marked, because you have to mark all the zeros or even ones for that matter here, so that what happens is that here this is assigned, so you see that this has to be marked. So this has to be marked. So you see that this one marked. So you see that I am just taking this one as my next least assignment. So when I assign this, naturally all the zeros or ones must be marked. And here this 0 is assigned, therefore this 1 has to be marked, because we are taking 1 as also next least for assignment. Then when this is marked, see, next you see that this is assigned, this 0 is assigned, and therefore when this is assigned, this is marked. When this is assigned, this is marked. When this is assigned, this 0 is marked. So you see that when this 1 is assigned, here this 0 is naturally marked. When this 1 is assigned, this becomes marked. So this 0 is left untouched. That means what? It is not marked, for reasons that there is no assignment here or there is no assignment in this. So you see that naturally this has to be assigned. So when you assign this, what is that you get here? Now, so this one, this is marked. So this is marked. This is assigned, and this is it. Now you see that A to D, then D to B, D to B, B to C, C to E, E to E. So you see that we are getting the root condition is satisfied, in the sense that he starts on the traveling salesman starts from A, goes to D, then from D he goes to B, from B he goes to C, from C he goes to E, and from E he goes to A, and hence the root condition is satisfied. Now what is the distance traveled? So distance traveled by TSM. See, from A to B, A to D. See, A to D, what is the distance? A to D, can you see this? A to D is 3. Then he goes from D to B. D to B is 3. Then B to C. B to C, what is that? B to C is 6. C to E. What is your C to E? C to E is 5. And E to A is 4. So you see that from to distance in kilometers. Distance in kilometers. So what is that you are having? So you see that this is how we do the problem, and so he will not violate he will go by this, he will go to A to D, D to B, C to then C, E, A, and the total distance covered will be 21. It is the minimum, it cannot go still further. This is the minimum he has to travel. So this is how we do this. The only thing is you should have understood how I am getting this. Here you see that when you use the zeros, see, it is the root condition not satisfied. Root condition not satisfied. So not satisfied. Here you see that this is not satisfied. Therefore, I will write here. See, it was previously A to D. I will put it here. See, A, B, C, D, E. A, B, C, D, E. Then it is infinity. It is 0 to 0 is assigned, 0 marked. Then it is 0 infinity, 1 is assigned, 0 marked, 0 marked. Then it is 2, it is 1, it is into infinity, 3, 1. Then D is into 0 mark assigned, 3 infinity, 4. This is assigned 0 into 4 infinity. So this one, the first assignment made, this did not satisfy the root condition, and therefore we changed this. Now the new one, so this is optimal. This is so you see that this satisfies the root condition. Root condition satisfied, but root condition not satisfied. Here you just set, say here this is not satisfied. So here the root condition is not satisfied, here the root condition is satisfied, and the distance traveled is what? The minimum is 21, and for this is how the problem is done. So this is quite a good problem. Normally they ask in the university examination. Take care of this. I will do more problems in different topics in the coming days. Thank you.